Hello, I'm Rashab,
I'm Joseph.
and this is the final demo of our DHT project for CSE434 computer networks.
Yes.
So there are seven terminals here, one for the manager and six for the peers that'll be part of the network. I'm going to start the manager first.
For part A and B,
For
we're
parts
going
A
to
and B,
yeah,
we're going to show
we're going
how
to
this
run the
works.
Python for the manager file and peer
The
files.
manager is currently running on localhost 127.0.0.1 on port 2000. Oh, right. I don't need to put an IP address here. I just need to put a port number. So it's good that we got that
Yes.
error early on in the video. The manager is
But for the
running.
connection
Now
with
we
the
can
peer,
start
we need
running the peers here.
we
Python
need the
peer.py. Peer.py here is just representing the shell file that runs the peers and has the peer
yeah.
functionality in it. These will need an IP address here.
To connect to the
127.0.0.1 is the local host IP address. It just ensures that they're running on the same port as the manager. 2000 here is the manager's port. 2001, at least for the first peer, is going to be the peer's communication port with the manager. The second port number here, 2002, is the peer-to-peer communication port from the very first host.
yeah. And each peer will have his own peer
Correct.
port and
Peers
his
will
peer
have their
communication
own
port.
name. I am fumbling hard today.
Okay, it's fine. So we forgot to add the name for the peer, so we named
Right.
it peer 1.
So
we're
we've
gonna do
named it
something
peer
with other
1, and
peers.
we're going to repeat this process 6 different times here. This will be peer number 2 in the order 127.0.0.1. They're all going to be connected to 2000 since that's the manager. Since both 2001 and 2002 are taken, the ports here will be 2003 and 2004.
A port for the peer and a port for the peer-to-peer connection.
Correct. And this is the third peer, so Python peer.py, peer number 3, 127.0.0.1, as all the others have been. 2000 for the manager, 2005 since 1 through 4 are taken, and 2006 for the P2P interface. We'll keep moving here. Python peer.py, peer 4, and this will be again 127.0.0.1.
It's gonna be
2000. It will be 2007 and 2008 since 1 through 6 are all taken at this point. Did I put something wrong here? Peer 4, peer.py, peer name, minute. I forgot to put. I did put the manager IP. What did I do wrong here? Python peer.
Maybe you have an extra line.
No, I don't think so. I don't think I have an extra line anywhere. But I can always check that. It's good to get these errors early in the video. That'll give us an idea as to what we're doing here and why we're getting errors here. Yeah, there we go. There's that space. I was missing that space there.
I was thinking about the space.
2007, 2008.
No, the peer.
No, this is correct. Oh, yeah, thank you. 2000, 2007, 2008. And this is peer 4, and we're going to continue this process here. We're going to run peer 5, peer.py. This is the 5th peer that we're making, peer 5, also on 127.0.0.1. This one will be 2000 again for the manager, but this will be 2009 and 2010 for the 2 ports, the M port and the P2P port. And lastly, we're going to run the 6th peer here, peer.py, peer 6. 127.0.0.1 like the rest of them, and this will be 2000, and since 1 through 10 are all taken, this will be 2011 and 2012. And now we have 6 peers. Let's designate peer 1 to be the leader and ask it to set up the DHT here. Set up the DHT, 5 nodes.
We need to register them first.
Oh, yes, thank you.
Yeah.
Making all the mistakes today, are we? Register this peer, so peer 1 on the IP address 127.0.0.1, and we're just going to go down the line, registering them all one at a time. Register
You can just copy the command and change. I think easier.
That's fine. I'd rather type it.
Yeah.
Register peer 3 127. Oops. 127.0.0.1. We're just going to keep registering these peers. I believe there's been an error here. Again, or good to get these errors early in the video. Peer 3, 127.0.0.1. There we go. Registered peer 3. We're going to register peer 4, 5, and 6. Peer 4, 127.
Just to catch errors because it shows that the code is robust.
Right. The errors actually are a good thing because they show that the code isn't, you know.
It's robust, basically.
Exactly.
So
yeah. As my partner Joseph just said, it shows the robustness and the fact that the code actually is designed to withstand a little bit of abuse from the coders, but hey, that's normal in coding, isn't it?
You have multiple
There we go. So we have 6 peers registered. As you can see over here, they were registered in order 1, 2, 3, 4, 5, 6. So now we're going to do the setup function, setup 5, 1996. What this will do is once I put that path into the file, it'll set up a DHT with 5 nodes with the year that it's expecting being 1996. There you go. As you can see, the peers that are in the DHT are 1, 3, 4, 5, and 6, leaving 2 out of the DHT.
It just randomly picked, so...
It randomly picked them, so there's no guarantee that it would always have been 1 through 5. And you can see here assigned ID 0 in the DHT of size 5, meaning that that's the leader. So that is part D done. So the remaining peer that's left is peer 2. And we'll have peer 2 issue a query here for event ID 2402920. That's the one we've been testing with the most, so I feel like it's only right we use that in the final test. And you can see the response came up back with success that peer 6 contains that event. Now we're going to have a peer in the DHT itself issue a leave command here. So we'll have peer 3 here in the middle. I don't know if you can see this. This is peer 3. We're going to have peer 3 leave the DHT here. DHT, you can see here on the right-hand side, leave DHT peer 3. Peer 3 has left. Now we're going to issue a...
Call immediately rebuild, right?
We did call immediately rebuild here. As you can see, leave completed DHT rebuilt, indicating that DHT rebuilt was called. So now we will ask from the one that just left, which is peer 3. We will ask for the following event, 5539287, and it should end up forwarding. So it hot potato routed all the way around and ended up forwarding it all the way around the ring without finding it.
And this was part F done, so now we're going to part G.
That is part F done. We're going to move on to part G here, which is the 2 that are outside the DHT. We're going to have 3 walk itself back into the DHT by doing a join command. We'll have the peer join the DHT back. We are back in the DHT. That's part G there. We're going to issue the query here again for the same event that we had before. So we will issue this query again, and it should come back with peer 6, who the original owner of that event was in the DHT of size 5, indicating that the DHT was rebuilt properly. So the leader here is still peer 1. As we can see, the DHT has been rebuilt a couple of times. 0 was the original ID after the rebuild. So we're just going to issue teardown commands from every peer to figure out which one the leader is. We don't know at the moment because the leader is chosen at random. So it's not 1, it's not 3, so it's either 4, 5, or 6. We'll find out. It's not 4. It's okay. So we know now that the leader is peer 5 here. You can see response success, teardown initiated.
The leader changed after the leave and join commands randomly.
Sorry?
Yeah, I'm just saying that the leader was...
right. Sorry. Yes, and then we have the leader issue the teardown-dht, and it's been a sufficient amount of time. The DHT's been... the teardown has been completed, so now we're going to issue a teardown complete, saying that the DHT has been torn down, and then we'll start deregistering deregistering each of these peers one at a time. And as you can see, the success here indicates that the DHT was successfully torn down. If there's any errors, we'll know that the DHT was not torn down, but the fact that... So everybody's been deregistered, 1 through 6. Yes, they were deregistered in a random order, but they're all deregistered. Now we can exit the terminals. We can gracefully terminate the little peer shells here. And as you can see, it goes back to the prompt that it was before, indicating the group name and the project. And lastly, once all of these have been deregistered and all the shells have been terminated, we can now hit Control C on the manager, ending this project.